Okay, today I want to show you how to use a combination of Google Scholar Labs and Notes and Notebooklm to to efficiently use AI for their information gathering or literature research. And we want to do it in a way that is fast, accurate, and complete. So maybe I can explain the idea in this slide. So the idea is we want to use AI for us to get information very fast and very importantly accurate, which is a key, I would say, key requirement for doing research, and also complete. Right. So the AI can help us to build basically a topic-specific database that we can interact with the AI in the following steps. So one of the current problems um, facing AI4Science is actually AI is not able to access the proprietary information. AI doesn't have the database subscription, right? So, but when it comes to research, those papers in the database, they're very important. So to address this kind of conflict, we introduce some kind of a manual steps. So it's basically this combination of both AI guided and human guided steps. We will use the help with Google Scholar Labs, and so we can search their citation information, and then we'll save them into the Google library, and then we'll export them to the Endnote. In Endnote, we're basically trying to do the batch downloading. So as long as you have the VPN, you have the subscription, you can try to do the batch downloading in the Endnote. Right? So this will save us some time from doing the accessing papers one by one. After we obtain those papers that we downloaded from the database, and then we'll feed those papers into the notebook. And then once AI has access to all those information, we are free to go in the following steps, including drawing schematics, making summaries, or even having some kind of interactive conversations with AI. So this is generally the whole workflow. So we can start by showing an example. I have opened the Google Scholar Labs. So if you go to Google Scholar, you will see there's some advertisements showing they have new functionality called the collabs. You may have to submit a request to obtain this capability. So I did the request some time ago and quickly got approved. So now I'm directly in their labs webpage. So one example is we want to understand the gassing mechanism in sodium batteries. Right. So this is one of our research topic. So you see the AI is already doing some search, and the AI is already helping us in this stage by analyzing all the papers and their conclusions and see the relevance to the topics that we're interested in. So we have some papers coming up. So it's still doing the evaluation. So normally AI would first generate 10 papers that are most relevant. And then we can, so see now it's coming out the 10 relevant papers, but we can ask AI to show more by clicking on the more results. So that will lead us to another 10 papers, right? A rule of thumb is we have to consider the capacity of Notebooklm that we will use to process those papers. Our current experience is for Notebooklm, its accuracy is best if we can limit the number of papers within 20 to 30. Beyond that, it starts to show some inaccuracies and inconsistencies. So I would suggest we feed AI Notebooklm with 20 papers, but for demonstration purpose, I'm just showing their how to do with their first 10 papers. But the idea is the same for the following papers, right? So for each paper, we see there's a star in this area. So if we click on the star, it will ask us to save to the library. So we'll save to the gassing library. We do that for all the papers. Save, gassing. Okay. Save, gassing. So this is not saving the real paper. This is only saving the citations. But this information is very useful for Endnote because we can use those information to do the batch downloading in Endnote later. So we save them into gassing folder. And by the way, gassing is some folder I have already created in library, but you can create a new if you want. So you see the button here, gassing. Okay, so now we have obtained all the 10 papers, and we can go to the scholars, my library. So you see the my folders are on the left hand side. So gassing is the folder that we just have been working on. So there are 10 papers in this page. We can export all and choose a format of EndNote. So this gives us a file that contains the citation of all those 10 files. And we download it and we click on it, and this will directly lead us to the EndNote. So which is shown here. Okay. So we already clicked on the file, so it's already open in Endnote. These are the 10 files that we just accessed. So here we can right-click, find full text. We're doing this as a way to trying to do the batch downloading, so we can obtain all the PDF files for those papers, and then we'll feed those PDF files into Notebooklm. So you see that you only found the URL for one paper, and there are 9 of them is not found. But no worries, we'll use this button, find the reference updates, because the citation form from Google Scholar is sometimes a little bit messy. It is not fully consistent with their Web of Science or EndNote really likes. So we just update all the fields, and we do that for all the 10 papers we have in this folder. Yeah. So it will address the inconsistency in terms of the citation format for the Google Scholar and EndNote. So so we'll see it's still working on it. And now we are close to the completion. Okay, so we're to find the full text again. Okay, so it's making progress. It's found the PDF for 4 of them. Oh, 5, okay. Still searching. 6, okay, I think that's good. 7, wow. So 8, I think it's pretty good. So for those 10 papers, Notebook EndNote is able to find the 8 of them. So we have 2 that is missing. So this one, we can really open the website, so we can kind of do it manually. But it still saves time because we do not have many papers to do for this. We'll find the full text, and we download it. So this will be it will be saved to my download folder. So I will attach that file to this citation. So this is the new file, and I will do that again for this remaining paper. Open URL. Sometimes we cannot obtain the full text because some database they're very sensitive to their multiple requests, so they will automatically block multiple downloading requests, especially Elseville. So you see the two papers actually are from Elseville. So we'll attach this one also to this. So now we will have all the files, not just citations, but the exact files associated with those papers now, right? So okay, so we will have these 10 papers and add them to the new group, and this new group we'll just call it gassing, and we'll save it. Save a copy. And so you see, I already work on this. So there was a file here, but I want to override it. And I already put it in the gassing folder. So I'll just save it. Save. Okay. And now let's go to the folder that has those PDF files. Type gassing. Okay, PDF. So you see in the PDF folder, we have all the folders. So each paper corresponds to your folder. So we just search the file extend PDF, which is PDF here. And now we have all the PDF file listed. And we just compress them to the zip file. So it will place on their desktop. Okay, so now we should have a folder on their desktop that contains all their PDF files. Which I believe should be I think it's well, let's see where it is. Well, anyway, we'll go to their desktop and find it. Data modified. Yeah, this I think this is the one. Okay, so so yeah, this is the one. So we'll extract all and extract. Yeah. Okay, now we have the PDF files in the one folder, and we'll upload it into Notebooklm. So I'll open my Notebooklm. And I create a new notebook, and I'll just drag them. Yeah, I like to drag them around, and I'll just drag them into this folder, into the source here. Okay, so now it's uploading all those files into the Notebooklm, and this is the completion of building our own database, right? And this is topic specific. It is specific on the gassing, and it has already been processed by AI in the Google Scholar Labs, so the information should be very relevant. Okay, a little bit wow. Okay, now we have all the 10 papers digested. We can generate reports. For example, so we'll ask for some suggestions. And for reports, we can choose, for example, a technical research report. Right, so it will start generating reports, and also we can ask it AI to do the slide deck. So it will have slides, usually around 12 to 15 slides summarizing what has been discussed in those 10 papers. And also we can have the mind map. So the mind map is basically showing the logics among those. For example, how to detect them, what is the chemical nature of the reactions, and how that influenced the Coulombic efficiency, so on and forth. Okay, but now with of this kind of a database build, we can really go further. For example, we can start directly do the interactive conversation by asking, what is the gassing mechanism of EC? Right. Let's see, ethylene carbonate. See how the gassing mechanism of ethylene carbonate is discussed in among those papers. At the same time, you see AI is still working on the slide deck and the report. So the AI is analyzing those papers and focusing on this specific topic. So we see the work is doing it. It's really going through analysis process, right? So now we have this kind of summarized analysis showing that what is really the mechanism. For example, this is what kind of a gas is generated, right? So apparently, EC really leads to the ethylene generation. And what is the mechanism of this kind of a generation? For example, it shows that when EC reacts with sodium ion and also in the presence of electron, so we can form the sodium EDC and ethylene gas, right? And the nature is basically a nucleophilic attack, right? And also there's some bond dissociation, and also some other gas form can be generated from the EC, including carbon monoxide, carbon dioxide, etc., right? And also including the hydrogen gas. But in all those subsections, they have the detailed analysis what is contributing to this generation process. Yeah. And in fact, we can also utilize this to as the preparation of the imaging generation. For example, generate image prompts for ethylene generation pathway, right? So this will ask AI to generate the prompts, and we will use prompts to generate the image in notebook. I'm sorry, in Nano Banana image. And those prompts they're very specific, and they're more accurate than what we just do it by ourselves, um, because we may not have the full information. Okay, so this is the prompts that AI generates, right? So it also gives the possible different scenarios. We can choose one from these different scenarios. So I think that maybe we can try the first one, the molecular mechanism, right? So we'll just copy and paste. So we'll start with the imaging prompt, the subject, to here. We'll just copy this part, and let's go to Gemini. And we'll ask Gemini to generate the image for us. So by clicking on the create image, we'll just paste the prompts and see what kind of illustration image that the Gemini can give to us. So so we see the prompts; they're pretty systematic, right? It has all the key information that is summarized from those 10 papers. Wow, so okay, it's pretty fancy. So I think there, well, the molecule is not drawn very accurately. So this is not ethylene carbonate, right? So we still have some details to work on for the accuracies, but this looks like a pretty fancy image. But of course, you can also choose other scenarios to do the illustration. Okay, so that's how we can really use this combination of tools to expedite the research process.